Hello everyone, and welcome to a series about teaching science in the FET phase, that is grades 10, 11 and 12. This series is aimed at science teachers in the FET phase and everyone else who's interested in education in South Africa. Let's first start by looking at our video on electrochemistry. It's early morning at Vulamazibuko Senior School in Mdantsane, just outside the city of East London in the Eastern Cape. Mrs. Makapela is preparing for her grade 12 chemistry class, setting up the experiments for today's lesson. When the learners have completed the practical investigations, they should be able to work together in groups, develop manipulation skills as they assemble and use electrochemical apparatus, apply their theoretical knowledge to their practical experience, and describe one industrial application of electrochemistry.
Good morning, class. Today you are going to do another very interesting lesson, which is a follow-up lesson on what we last did. You can remember that we did a lesson on redox reactions.
Vulamazibuko does not have all the facilities and apparatus it needs to conduct experiments. To counter this lack of equipment, Mrs. Makapela will use a circus of experiments to conduct today's lesson.
We are going to be able to see that these solutions are able to conduct electricity. We must, in fact, learn science to be able to apply it. So whichever lesson we learn, we must be able to understand how is it going to help us. So these electrochemical cells are used in a process in industry which is known as electrolysis. But we'll explain about that after we have set up our experiments.
We're going to pour copper sulfate, combo green. We pour potassium nitrate.
The advantage of using a circus of activities is the fact that you can be able to set up many experiments in one day and having the students to be able to manipulate all sorts of experiments. Like in our circus today, we had 3 experiments where the students were able to observe all 3 experiments in one day.
It is important for the learners to set up the experiments themselves, to get a hands-on experience of the equipment and chemicals and make their own first-hand observations.
Copper sulfate, and then we take this one and put in the zinc sulfate.
It's difficult to do a circus in an ordinary classroom with sloping desks where there's a lot of desks crowded into a classroom. But I think the teacher's got to use his or her initiative there, and perhaps the classroom isn't appropriate, and then perhaps what they have to do is to say half the class can go and work on some worksheets perhaps while half the class is doing an experiment, and then the next period they swap around. That's a variation on the circus idea.
In the first experiment of the circus, the learners are investigating a zinc copper cell. Learners insert a salt bridge made from tissue into the prepared solutions and connect the voltmeter. The purpose of the experiment is to observe the spontaneous generation of electricity when there's a difference in potential between 2 metals and their salt solutions, even when they're in separate containers. The learners will determine which metal is oxidized and which is reduced by observing changes at the cathode and anode.
Or you've got to be good at time management if you're using a circus, because you've got to know about how much time you'd need on each experiment. And you don't want one group finishing an experiment that's quick and easy and then hanging around or crowding around a slow experiment. So you need to make sure that your experiments take about the same time. And then you need to watch the clock quite carefully because you want each group to get around to all of them. So you have to select which experiments you can do quite cleverly.
At the second stage of the circus of experiments, the learners pass an electric current through a solution of copper chloride. They will deduce what chemical change has occurred by observing any changes at the cathode and anode. In the final stage of the circus, the learners conduct an electrolysis of water experiment. The learners investigate the effect of passing electricity through water and use their knowledge of the chemistry of water to deduce which gases are released at the cathode and anode.
I think everybody has finished setting up the experiments. I hope that you have been able to make observations on your own, which you will try and explain. Okay, people, I think your experiment has been going for some time.
After each of the groups of learners have set up the experiment and have made their observations, Mrs. Makapela moves from group to group, asking probing questions to assess the learners' level of understanding of each experiment. The learners have a good chance to tell what they have observed and what it means.
Can you see anything different there?
Yes. We have copper formed underneath the electrode.
Okay, he's saying we have copper forming. Okay, normally, if something is in the form of bubbles, it means it's what?
It's a gas.
Okay, so possibly, what is that gas?
It should be chlorine.
It should be chlorine. Okay, people, in our everyday life, where have you ever seen chlorine being used? What do we use chlorine for?
I think we use chlorine for bleaching.
Okay, we use chlorine for bleaching, and there's one other important use of chlorine in everyday life.
We use it as a cleaning agent. For instance, we use it to clean swimming pools.
Can you just put this strip onto the side which we think has chlorine and see what the effect of that chlorine will be on that strip of paper?
Mrs. Makapela spends time with each group of students and their experiments. She goes through the experiments with the students, probing their understanding of the experiments. She asks all the students what the different aspects mean.
Really, we can see that it was yellow and it's turning white. So really, that is chlorine. It's a bleaching agent. Ne? The concepts of oxidation and reduction are difficult. In fact, if you refer to them as that, what the students need to understand is basic chemistry. In fact, where you start with explaining to them the periodic table, you explain to them the electrons, you're explaining to them that some elements are able to gain electrons and some are able to lose electrons. So I think what is important is to teach the students basic chemistry. And then, can you do something for me? Can you lift your salt?
She gives each group enough time to ensure they've understood the purpose of each experiment before moving to the next group.
And what do we observe if we lift the salt bridge?
There's no light.
There will be no light. Yeah? So, what does that tell you?
It provides electrical connection between the two solutions. That's the function of the salt bridge.
And then, can you have a look at your zinc wire and see what has happened to your zinc wire? Yeah, can you take it out? Okay. Oh, and the zinc wire, what has happened to zinc?
Zinc lose atoms.
Atoms of...
Zinc lose ions and
No, zinc is in the form of ions, so it has lost electrons. Ne? With teachers which actually have a problem with equipment, truly speaking, within an area, there's not one single school within that area which does not have equipment. So if teachers can form associations and then, let's say within 1 week, you organize a central venue where you can have schools coming to that venue, maybe on a Saturday. You set up the experiments and let the students do the experiments or watch the experiments being done by educators. That can help.
At the next group, Mrs. Makapela again recaps the experiment.
And it's very interesting because you have observed that water can act as an electrolyte. And if you can still remember, in grade 10, electrolytes are those which can be able to conduct electricity. And you can see that you have this lighting because current has been flowing there. Okay? What have you observed in your experiment? What actually happened in your experiment when you connected your electrodes?
Inside the two electrodes, they are filled with water, and one of the electrodes has more bubbles.
You said you have water in the form of ions. So now, if you have gases, which gases do you think will be formed?
There is a hydrogen gas and oxygen gas.
which one has been formed by a gain of electrons? You are saying there's a hydrogen gas and an oxygen gas, and which one has been formed by?
When Mrs. Makapela is satisfied with the level of understanding of the learners, they move on to the next stage of the circus and a new experiment.
Okay, I think our lesson was very interesting because we're able to manipulate apparatus and to be able to make observations on our own, and then we have been able to actually see our redox reactions in action, and we have been able to see also that they can be able to conduct electricity. And then on our next lesson, we'll be doing calculations which involve our electrochemical cells.
I thought she did quite well. She set up the class nicely and then got them going. You could see in their faces that they were itching to get on with the experiments. And then she made them move on after about 10 minutes, I think she gave them on each one, which was enough to see the reaction. But perhaps over the time of the lesson, you'd get a result on each experiment. And then she pulled it together at the end quite nicely.
Now that we've seen our video, time for us to welcome our guests. We've got Marissa Rolnick from the Wits School of Science Education, and we've got Kanye Zwane from Science Education Project, and Feroza Esop from Northview High School. Thank you for joining us. Let me start with you, Marissa. Do you think the circus of experiment strategy is an effective way of using limited resources effectively?
Yeah, I think it's a very good way of doing it, but it does call for a lot of organization on the part of the teacher. And careful timing. For example, if there are experiments that take a long time, you might need to have 2 setups of those.
Okay. Can you?
Yeah, the other thing is your learners must have done that, you know. They must be prepared, they must know in advance what practicals there will be, what knowledge they should prepare. Otherwise, it would just be a fanfare.
Okay. Feroza?
It's a good way of using limited resources, but I think a lot of care has to be taken that you choose your experiments carefully, because often with the weaker learners, you cannot have them, you know, having too much an overload of information. You know, I find often, especially for the weaker learners, you need to, you know, do things a little more slowly, or you know, not excess information for them. So I think the experiments that are taken must be chosen carefully so that they can deal with each one, you know, effectively.
Now, what are the main difficulties that learners have with electrochemistry, and how should teachers help them?
The problem with electrochemistry, I think, is that it's at a very microscopic level. You know, the redox reactions, the half reactions, oxidation, reduction. Learners can't, you know, copper ions. They understand what copper is, but, you know, copper ions. So I think the fact that it's on such a microscopic level, that leads to a lot of difficulty for the learners. As to how teachers should help them, well, I think when the practicals are done, when the experiments are done, I think to simultaneously reinforce, you know, for example, when they see a solution that turns blue with the copper ions, then actually write the equation down and show them that, you know, it was copper that has now been oxidized to copper ions. So in other words, I would imagine to try and bring in the microscopic simultaneously when they see the microscopic changes that occur.
Okay. Can you?
I would agree with Faraz on that point, because in this lesson there was a heavy leaning on what they can observe. I think the teacher did mention what they can observe, and yet the observation should be answering the hypothesis they had, the purpose. So for me, the practical observation part was done very well. What needed to be done was, as Faraz says, link whatever observation with the micro, what it means. What are the compounds that we used, in what stage were they, at what stage do they get to form ions, and then to show the reduction, if it's a reduction, or the oxidation. Because if the learners having seen that, you'd give them a test, for example, or some work on the same thing, but using symbols, very few of them will be able to write what they've seen, you know, because that link was not created.
Okay. Marissa?
Well, Faraz has mentioned the micro, Kanye's mentioned the macro, the symbolic. There are a couple of well-established difficulties that learners have apart from the ones that have already been mentioned. One of them is the circus that the learners were doing in that video had both electrolysis and electrochemical cells. And these are two very different things. In electrolysis, you have a battery or an electricity supply, and you cause a chemical reaction that isn't going to happen on its own. And in the case of the electrochemistry, you have a spontaneous chemical reaction that is causing electricity. And that's quite exciting because that's how batteries work. That's how we make electricity. But in the other one, we're using electricity to make a chemical reaction happen. So that needs to be really carefully pointed out and possibly not even done on the same day. The other one that I'm aware that learners have a lot of difficulty with is understanding what the function of the salt bridge is in the electrochemical cell. The teacher did allude to it, but I think the explanation that she got from the learner was a little bit superficial, because some of the learners think that electrons flow through the salt bridge, whereas it's actually ions that flow through the salt bridge. On the other hand, there was one point at which she did actually touch on the micro level. She was referring to zinc ions, which I think, she just could have done more of it, as Verosa said.
Could I just add to what Marissa said? In my experience, I found, let's just take the copper zinc cell. You tell the learners that zinc is the anode and copper is the cathode, and they go along with you. But no one ever asks you, but why is zinc the anode and why is copper the cathode? I mean, how do you know that copper is not the anode? That is often a big difficulty they have as well. If you give them something that you don't actually tell them about, let's say a magnesium aluminium cell, many of them will not know or understand how to determine which is going to be the anode and which is going to be the cathode, and I think that's often a big problem as well with electrochemistry, with electrochemicals.
And that's another thing with the difference between electrolysis and electrochemistry, because in the one case, people tend to refer to the positive and the negative electrode, and that's even more confusing. They should rather always identify the anode where the oxidation takes place and the cathode where the reduction takes place.
Okay. Which is why I also think, had she had some blackboard used, drawing the cells, representing each of those reactions, it would have made life much easier for the learners.
Okay.
Yes.
Now, do you think the teacher managed time effectively in the class?
Time-wise, yes.
Okay, why do you say that?
Because it looked like there was a beginning, and then there was a part when they're doing the practical, and there was some consolidation. And one strong point of the teacher, she asked them per group questions. She drew answers for each substation from the group.
Okay. Marissa?
I think this teacher was lucky because she had quite a small class. I think the real difficulty with time management would come when you have a larger class
group.
And you've really got to be strict on getting the groups to move on to the next experiment if you really want to finish in the time.
Okay. Verosa?
It looked, from what I saw, she seemed to do a reasonable job with time management. So.
Okay. Now, do you think the teacher's references to everyday life were useful? For example, the relating to uses of chlorine, for example.
Yeah, I think it was. It's always good to bring in everyday life. I think she could have mentioned, though, that chlorine, or I think that the learners mentioned that it was bleaching, and they said something about cleaning swimming pools. And I think it could have been mentioned also that it's a good disinfectant. The water that you drink as well. So, I agree that it should be, everyday life should always be brought into the picture.
Be part of the lesson.
Yeah.
Can you?
I think she used a very good example with that bleaching paper. She had a yellow paper and put it at the mouth of the chlorine, so the learners could see, even someone who would know what is bleaching is, the bleaching action taking place.
Marissa?
The one thing with the chlorine that I thought she could have done is chlorine's got a very distinctive smell. And it's only with the microscale apparatus that you can actually do that in the classroom without having a fume cupboard, because chlorine is a poisonous gas. But fortunately, with the microscale equipment, the quantities are small, so nobody's going to get poisoned. But they should have been able to pick up that very characteristic smell of chlorine. And that's one of the things I would have also asked, in addition to bleaching and so on.
Okay. Any other issues relating to the video? Can you?
No, I think I'm covered.
You're right.
Yeah.
Marissa?
Yeah, just one other thing about a circus is it doesn't all have to be experiments. You can have stations where there are worksheets and they just have to solve problems. So if there isn't enough apparatus, for example, let's say you've got a class of 40 students and you've got 8 groups of 5. So you haven't got enough to set up 8 things. You could at some stations set up things which are not practicals, but other kinds of pencil and paper activities that the learners could do, even some discussion type things.
Okay. Rosa?
I'd like to see, you know, more involvement from the learners, asking questions, you know, not just answering the questions always. And also, for example, in the end where there was the electrolysis of water, and she asked the learners what gases, and they said hydrogen and oxygen, perhaps to go forward and ask them, well, where do you think the hydrogen comes from, you know, relating to the formula of water, you know, trying to always build up on what they see to what they know inherently, with, you know, trying to link again what they see to, you know, the formulae and the equations, that kind of thing.
Okay. Well, that's how we come to the end of the session. Thank you very much for joining us. Our guests, that's Marissa, Kanye, and Feroza. And to our viewers, thank you very much for joining us. Do keep your eyes peeled for the next module. Thank you. Goodbye.